Hi guys, this is gonna be the video explaining week 13 recitation guide. I will just go over this for this video. If you have any questions, you can contact me via email. Don't doubt and don't hesitate in contacting me. I would like to point out before I start that I have received a few emails regarding the grades for laboratory number 8. We have until Wednesday to upload those notes, those grades, so expect them next Wednesday. Anyways, don't worry if you see any low grades so far in your report. That doesn't mean nothing. That means that the system is automatically filling those spaces that can be automatically graded. I haven't graded nothing so far, so don't worry about that. Having said that, remember that your exam is next April 15th, which is not this Wednesday, the other one from the upcoming week. So keep that in mind. And remember that you still have time to upload or to submit your laboratory number 9. So keep that in mind as well. Let's start briefly. So they are asking me here that for the following reaction, and they are reacting 2 moles of SO2 with 1 mole of oxygen to form 2 moles of SO3. And they are asking me about the mole ratios between basically the 3 molecules I have in there. So when they are asking me about the ratio, you just need to take a look at the amount of moles you have per each one of the molecules involved in the ratio. If they are asking me about SO2 and oxygen, I need to look at the coefficients each one of it has. And if you take a look at it, SO2 has 2 moles, so that means that I have a 2 by and the amount of moles you have for oxygen. In this case, you know that's a 1, so this is going to be a 2-to-1 ratio. Conversely, and if we look, this is going to be A. Now let's go for B. B, it's going to be SO2. We already know that that's 2 moles. And for SO3, if you look at it, you have 2 as well. So you have a 2 to 2, which is the same as saying, oops, let's change colors. Let's go here. Which is the same as saying a 1-to-1 ratio. Exact same thing. Moving forward, second question is related to the acid-base titration or neutralization you have in there, where you are reacting 1 mole of sulfuric acid with 2 moles of sodium hydroxide to form 1 mole of sodium sulfate and 2 moles of water. They are asking me about the amount of moles of sodium hydroxide that are needed to neutralize 1.25 moles of sulfuric acid. So if I have 1.25 moles of H2SO4, if you recall from previous lessons and recordings, you need to consider the stoichiometry of your reaction. Of course, and I forgot to mention this, but first of all, always, you need to check the chemical equation. It has to be balanced, otherwise you cannot do nothing. So that's gonna be the first step before anything. And in this case, if you check at that reaction is it's correct. So don't worry about that. You can keep moving, but please check that at all times. And now they are already giving me the moles, so I don't have to do any conversion besides the consideration of the ratio of the stoichiometry of my reaction. So in this case, if I have okay, so let's first of all check the ratio. I'm relating here sodium hydroxide with sulfuric acid, so I have 1 mole of sulfuric acid per each 2 moles of sodium hydroxide, and that's what you have to do here. So you know that you have 1 mole of H2SO4 per each 2 moles of sodium hydroxide. This goes away with this, and as you can see, in this case you need to start performing calculations because this is not a 1-to-1 ratio. Therefore, this is going to be 1.25 times 2, which equals to 2.5, and that's the amount of moles of sodium hydroxide you need to titrate or to neutralize those 1.25 moles of sulfuric acid. Now they are asking me about how many liters of 0.0250 molar of sodium hydroxide are needed to neutralize 1.25 moles of the sulfuric acid. So if you, let me check on this, how many liters? Okay, so you already know in this case the amount of moles, because if you take a look at it, they are asking you for the exact same amount of moles. So you already know that you have in there 2.5 moles of sodium hydroxide. If you recall, molarity equals to moles over liters, and they are asking in this case about volume. Therefore, you need to calculate volume. Liters will pass here and molarity here, so you know that liters is going to equal mole over molarity. And if you take a look at it, we have all the information. So moles is going to be 2.5 moles over my molarity, which is 0.0250 mole over liter. Moles cancels out with moles, and in the end you'll get liters, and that should be equal to 100 liters. That's a very big number. Okay, let's move on. So now they are asking me about how many milliliters of that same concentration of sodium hydroxide are needed to neutralize 10 mils of 0.045 molar of the sulfuric acid. So same thing. In this case, the first step is going to be find moles of my sulfuric acid. So you need to pass these to liters so you can make the conversion, and starting from this very same formula, if I want to find mole, you know that that's molarity times my volume. Therefore, in this case, that's going to be 0.045 moles per liter times 0.01 liters. Which is 4.5 times 10 to the minus 4 moles of sulfuric acid. So now the coming step to do in this case, how many milliliters of a specific concentration. So now you need to calculate the amount of moles that represents. Let me open up a little bit more space here so we can work this out. That thing of recording this live. Okay, now we have space. So now, second step, take those 4.5 times 10 to the minus 4 moles and relate it according to the equation. So it's the same step as you did in exercise number 1. So for each mole of, clarify this here, I have 2 moles of OH. This cancels out with this, and now you know that you have 9 times 10 to the minus 4 moles of sodium hydroxide, right? Now I have my moles. They are giving me, in this case, the concentration, and they are asking me for volume. So always, if you need to calculate volume, it's just gonna be moles over the molarity you have, and that's gonna equal your volume in liters. Recall that. So in this case, that means that you will have to go with 9 times 10 to the minus 4 mole of sodium hydroxide over your molarity. In this case, it's 0.025 mole over liter. Moles cancels out. The final answer will be expressed in liters, and that should be equal to 0. Let's say 0.04 liters. Okay, moving forward. Okay, so balance. Okay, so first of all, and for this question, you will have to balance the following reaction. You are reacting an amount of moles of nitrogen with an amount of moles of hydrogen to form, in this case, ammonium. So yeah, to form ammonia. So in this case, well, first of all, you need to take a look at this consideration. Okay, so here, sorry, the video got stopped. I didn't notice it. So okay, so we have to balance the following reaction. In this case, as I mentioned, you have a certain amount of moles of nitrogen with a certain amount of moles of hydrogen, forming, in this case, ammonia. So if you take a look at it, once I put this coefficient of 3 with my hydrogen, 1 is going to be the coefficient for nitrogen, and I get 2 moles of ammonia. If you do the math, this will make sense to you. So that's the balance equation. And now they are asking me about how many grams of hydrogen will react with 28 grams of nitrogen. So first of all, you need to pass those 28 grams of nitrogen to moles of nitrogen. If you recall, in this case, moles equals 2 grams over the molecular weight. So for nitrogen, just so you know, if you don't recall, it's gonna be 14 times 2 because you have 2 atoms of nitrogen, so that's gonna be 28 grams per mole. That's information you have so far. So now, making the conversion, you have 28 grams over 28 grams per mole. Grams goes out with grams, and in the end, you will get 1 mole of nitrogen. So you're working with 1 mole of nitrogen, and the final step will be, oh no, we have more steps, so let me open up more space here. Okay, now it seems fine. Okay, so this is gonna be the first step. Second step now is gonna be to pass from mole of nitrogen to mole of hydrogen, because that's what they are asking you for. So doing that is just taking a look at the stoichiometry you have between nitrogen and hydrogen. And if you notice, you have 1 mole of nitrogen per each 3 moles of hydrogen. So this is going to be this way, 1 to 3 ratio. So that's the ratio you will use if you have 1 mole of nitrogen. And let's say that for each mole of nitrogen I have 3 moles of hydrogen. This cancels out with this, and you know that in the end that means that you have 3 moles of hydrogen. Of course, if you saw the ratio in this case, you would have noticed that was the case, but I just wanted to show you the whole procedure just in case you don't understand what's going on. So in this case, moving forward, once we finish that part, we just need to pass as the third step from moles of hydrogen to grams of hydrogen. If you recall, in this case, the molecular weight for hydrogen is a very easy one, so this is not going to be a big issue. And if you recall, if you want to get grams is going to be equal to your moles times your molecular weight. So in this case, if you have 3 moles times 1 gram per mole, it's quite a bit, but I just want you guys to see the whole logic behind. That means that you will need 3 grams of hydrogen. And that's basically what's going on in there. Okay? So, moving forward, let me just make a box here. So for the acid-base neutralization reaction below, how many milliliters of 1 molar sodium hydroxide would be needed to completely neutralize 0.0080 moles of sulfuric acid? Same reaction as the one above, so you remember that you have a 1 to 2 ratio going on here, and if they are telling you that you have 0.0080 moles of H2SO4 or sulfuric acid, you need to make the relationship. Remember that you have 1 mole of H2SO4 for each mole of sodium hydroxide. This cancels out, and that means, for each 2 moles, actually, let me just erase this so you can understand better, because you need to understand what's going on there. There we go. And that should be 0.0. Live math is not very good, so let me just check on that. So I'm going to be sure I'm not making a mistake. Okay, that makes sense. So that's what I have of moles of sodium hydroxide. And now they are asking me how many milliliters of sodium hydroxide would be needed to completely neutralize that amount we just got. So now you have the moles of sodium hydroxide and you have the molarity. You just need to get the volume. If you don't recall how to do this, I will do this each time I'm explaining an exercise of molarity. So once again, molarity equals moles over liters. If they are asking you to get liters, you know that liters is going to equal moles over your molarity. Therefore, your final part in this exercise will be to get your volume, which is going to be equal in this case to 0.016 moles of sodium hydroxide over the molarity you have, which in this case is 1, so it's 1 mole per liter, So you know that moles goes away with moles, and in the end you will get liters, so 0.016 liters of sodium hydroxide are needed to neutralize 0.0018 moles of sodium sulfuric acid. Moving forward, let me make a box here. Okay. Now they are asking me to calculate the mass in grams of water produced from the combustion of 1 gallon, and they are telling you that 1 gallon equals to 3.8 liters of gasoline, C8H18, with enough oxygen. So if they are telling you that you have enough oxygen, you have to remember that that means that in this case, once the gasoline is over, the reaction is gonna stop. That's what that means. Each time you read enough of any kind of reagent, that means that you have enough of that reagent that will be the one stopping the reaction. The reaction in this case then will stop because of the gasoline. Once the gasoline is completely burned out, the reaction will stop. Okay? So this wording, it's important for you to understand that that means that you won't stop the reaction because of the oxygen, rather you will be stopping the reaction when the gasoline runs out. Okay? And they are telling you in this case the density of gasoline. So if they are telling me the density of gasoline, I know that I need to make any sort of conversion with those 3.8 liters of gasoline I have there. So let's make it, because remember they are asking you about mass. So first of all, you need to pass this from liters to milliliters. If you need to pass that from liters to milliliters, remember that you need to move your decimal point 3 spots to the right. So that's gonna be equal to 3800 milliliters. Let me check that. Yeah, okay. Milliliters of gasoline. And now we need to use the density to pass from volume to mass. So that's gonna be equal to 1 milliliter, 0.79 grams of gasoline. So that's gonna be 3800 times 0.79, which is done. Okay, equals to 9 grams. Remember, this is still gasoline. Perfect. And now they are asking me to calculate the mass of water produced from that combustion. So I need to pass from gasoline to water. So I need to consider in this case, in the stoichiometry, gasoline and water. Remember that in this case they are giving you the equation completely balanced, so you don't need to worry about that. However, once again I repeat this, you need to check your reaction prior to do anything. If it's not balanced, you won't get any right result. Keep that in mind. Okay, so that means that I need to check the stoichiometry. So first of all, I need to pass from grams of gasoline to moles of gasoline. Actually, let me make that step in here. So that means that I need to convert that. Let me put information here. Carbon weighs 2 grams per mole. Hydrogen weighs 1 gram per mole. I will just make that conversion. So that's gonna be 8 times 12 plus 18, which is 114. So I have 114 grams per each mole of gasoline. Okay, perfect. So grams will go in this case out with grams, and that means that 3002 over 114, which equals to 26.3 moles of CH18. Okay, but this is not the last part of the questions. Let me open up more space here for you. Okay, so moving forward, now they're asking me to calculate the mass of water. So I know that I have 26.3 moles of gasoline, and now I use the stoichiometry, and if you check the stoichiometry, that's telling you that you have 2 moles of gasoline per each 18 moles of water. This cancels out, and in the end you will get moles of water, which is what you care about in this case. So that's 26.3 times 18 over 2, and that's 237 moles of water. That's what you are supposed to get in the end. But they are asking me about the mass. So in this case, I will tell you the molecular weight for water is close to 18 grams per mole. So now, if I have my moles, that means that 237 moles of water times in 1 mole of water, I have 18 grams. So that's 237 times 18, which equals to 4266 grams of water. And that's gonna be your final answer for that question. If you have any questions, check. This is a video, so good for you. You can go back and forth and check the results, check the logic behind. If you have any further questions after you check the video, let me know via email. Moving forward, they are asking me now which of the following solutions, 1, 2, or 3, and they are putting 3 different boxes with different colors, different grading in a grayscale, and they are asking you which one of those would give the highest absorbance value when placed in a spectrophotometer. You have to recall that darker colors represents higher concentrations, and in this case they are asking you to explain your reasoning. So remember that if you are absorbing more because of the darkest the color is, the higher absorbance it has, that means that it has to be more concentrated. Therefore, in this case, the answer is quite obvious, and that means that number 1 should be the highest absorbance value. Oops, that moved. Why that happened? I have no idea. Anyways, so in this case, it should be number 1. Okay? So, about the explanation for this exercise, I would like you guys to think of it, starting from what I just said, plus what you have seen in your lectures. Keep in mind that the stronger the absorbance, the higher the concentration, because you have a linear relationship according to the Beer-Lowe equation. And that means that as absorbance increases, concentration has to increase as well. Keep that in mind. Number 7 and number 8 are for you, so think of that. And now regarding exam number 3 review, I would like to work some more exercises. So first of all, let's open up space here. Okay. Perfect. We have space. So a student titrated 25 mL of phosphoric acid having an unknown concentration. So I have 25 mL of phosphoric acid, let's say. So H3PO4 having an unknown concentration. So I don't know my concentration with 0.3 molar sodium hydroxide. and they are using in this case phenolphthalein as the indicator. The solution became a steady light pink after adding, so I will actually would be better to make the drawing here. This is what I have. Here I have my, so he's titrating the acid, so here he has the acid and he has here 25 mils of phosphoric acid, and here I have NaOH with a concentration of 0.3 molar. And they are telling me that in order for the student to titrate those 25 mils, he had to use 46.50 mils of the sodium hydroxide solution. And they are asking me about what's the original concentration for that phosphoric acid. Well, they are giving you here the formula. This is once again a titration, but once again you are changing the ratio. You are not in a one-to-one ratio anymore. In this case, you have a 1-to-3 ratio, and you need to keep that in mind at all times. As I mentioned, and once again I said the same, first of all, check your equation. It has to be balanced, and in this case, it is balanced, so you can keep working with that equation. So as I mentioned, keep in mind that in this case, you have a 1-to-3 ratio between the two components or the two reagents you are dealing with for the calculation. So let's start. I have done this before in a 4 steps representation or approach. The first step is to check the equation, so we already finished that step. The second step now will be to, let me check, do we have here? Okay, yeah. So you need to pass, hold on. Okay, yeah. So if you recall, molarity equal moles over liters. In this case, they are giving you for NaOH they are giving you the molarity and the volume. So you need to calculate in this case the moles of base you use. So in this case, mole is equal to molarity times liters, which equals to 0.3 mole per liter times 0.0465 liters. Cancels out. Let's do this real quick. That equals to 0.3 times 0.0465, which equals to 0.014 moles of sodium hydroxide. So now the third step is to pass from moles of NaOH to moles of phosphoric acid. And for this you need to consider the stoichiometry of the reaction. So 0.014 mole of NaOH times, you know that for each 3, in this case this is changing to 3 because this is a 1-to-3 ratio, so for each 3 moles of NaOH I have 1 mole of H3PO4. So 0.014 times 3 should be equal to 0.04 of H3PO4. So that's the amount of moles you have in this case of phosphoric acid. And the last step is just gonna be to relate, because they're asking you about temporality. So that's gonna be 0.04 mole of that acid over 0.025 liters. And that's equal to 1.7 mole. So this should be the concentration for your acid. If you have any extra question, please let me know. Moving forward, I will leave this for you because this is a very same equation you use for exercise or laboratory number 9. So it's a 1-to-1 ratio. It's a very simple one to do. So I encourage you guys to try that one. Let me check on this. This is solubility. You guys have worked with solubility before. I won't go over that. If you have any further questions, you can contact me during the recitation. And I guess that's it. So I will finish this video now. See you later, guys. Remember, contact me via email if you have any questions. Remember, exam number 3, it's gonna be April 15th. And keep in mind that your grades for laboratory number 8 should be up before Wednesday. So see you guys.